Okay guys, welcome to our first virtual classroom. We'll give this a try this week and see how it works, and we'll go from there. So I hope everybody's healthy and doing well. Let's just start with a word of prayer like we usually do. So dear Father God, I just thank you for this day. Lord, I thank you for keeping us all safe and sound. I thank you even for this time when we can be at home with our families, Lord, and I just pray your protection upon everybody enrolled in this class, upon our nation, upon our world. Lord, I pray that this could be a time of reflection for all of us, just to help us realize our own mortality and to make sure that in our hearts we are prepared to meet you. Lord, I pray that you would just be with this process today. I pray that you give me the words to speak and give the students understanding. And we just ask all these things in Jesus' name, amen. So when I was videoing my chemistry class, I figured out that it might be easier to break these videos into smaller pieces. So this first video is going to be a review of what we did prior to spring break. So if you remember, the week before spring break, we had started chapter 12 about optics, geometric optics. And one of the first things we learned was the law of reflection. And if you remember, the law of reflection just says that the angle of incidence is always equal to the angle of reflection. So if this horizontal line is a mirror and I draw this imaginary perpendicular line to that mirror, then I have a light source up here shining a light on my mirror. As such, it will be reflected back like this, where this angle is equal to this angle. Okay, and this first angle is the angle of incidence, and the angle that's created when the light beam reflects off of the mirror is the angle of reflection. Okay, so all the law of reflection tells us is that the angle of incidence always equals the angle of reflection. Okay, so that's the first thing we learned. Then we talked about different kinds of mirrors, specifically flat mirrors and spherical mirrors. And with spherical mirrors, we learned that there were two kinds, concave and convex. Okay, so if a person was standing out here in front of a concave mirror, it means the mirror would be shaped like this, like he's going into a cave. If he were standing in front of a convex mirror, it would be a mirror shaped like this, where he's kind of on the outside. Every spherical mirror has a radius and a focal point. Okay, and the radius is just the radius of the circle if this part of the circle were completed. Yikes, that's not a very good circle. But the radius is just this value here. Okay, we all know what the radius of the circle is. Okay, so if this spherical mirror, if we would complete the circle, draw the center, the radius is the length here. The focal point is just the radius divided by 2. Real simple, okay? So if this is our radius, our focal point would be about here. If this were our radius, the focal point would be about here. The reason these 2 points are important is because they help us with our ray tracings. And one key thing to remember is that all horizontal light beams shining in order to preserve this law of reflection, all horizontal light beams, it ends up, reflect back through the focal point. And there was a good picture of this in our textbook. Let's see. on page 389. Okay, so any horizontal light beam will reflect back through the focal point. All right, that's true, again, because of our law of reflection. So even in these spherical mirrors, the law of reflection is true, not only on flat mirrors, but also on spherical mirrors. Then the book talked a little bit about the difference between spherical mirrors and parabolic mirrors. There is some inaccuracy when learning or when using spherical mirrors, and parabolic mirrors are actually more accurate. In a spherical mirror, they won't all exactly intersect at exactly the focal point. In a parabolic mirror, all the reflecting light beams would go exactly through the focal point. But parabolic mirrors are a lot more expensive to make, not as readily available. For all everyday purposes, spherical mirrors are good enough. So that's what we're going to study. All right, then we talked a lot about ray tracings. Okay, so ray tracings is where we draw the picture trying to determine what the reflected object will look like, or how an object will be reflected. Will it be fat? Will it be short? Will it be tall? Will it be upside down? Will it be right side up? And there's a process to drawing these ray tracings that if you just follow the process, you'll nail it every time. So let's review what that process is. So the first thing we do is we draw the mirror. All right, you have to read the problem. Is it concave or convex? The second thing we do is draw a horizontal. Kind of be used as our reference point. Okay, this horizontal is actually called the optical axis. Okay, the third thing we do then is find R and F. So the book will either give you the radius or the focal point, and if it gives you one, you can easily find the other, because again, the focal point is just half of R. The next thing we do is we draw our little person in the right position based on where the focal point and the radius are. We then draw our 3 guidelines. Okay, and in class we use different colors. I'll probably try to use different colors today. So the first one we draw is a horizontal from the head, and it reflects back through the focal point. The next one we draw is from the head through focal point, reflecting back horizontal. So the blue or the purple and the orange line are kind of opposite each other. The orange is horizontal, reflecting back through the focal point. The purple is through the focal point, reflecting back horizontal. And the third line is the easiest one at all. From the radius, reflecting back through the radius. Okay. So after we've drawn those 3 lines, the next step is to determine where the lines intersect. And here is where we have to extrapolate if necessary. Extrapolate if necessary. Okay, so if the reflected lines intersect, great, you're good to go. If the reflected lines don't intersect, then you extrapolate them behind the mirror and find a point of intersection. Finally then, we draw a head at the point of intersection. And draw the body back to the horizontal. Okay, so let's do one of these, just walk through one of our homework problems since we haven't done this for a while. So let's look at problem on your own 12.1. So I'm on page 398. Okay, so it says an object is placed 4.5 centimeters away from a concave spherical mirror with a 12 centimeter radius of curvature. Draw a ray tracing to illustrate how the image will appear. Okay, so according to my steps, I need to draw the mirror first, all right? And this problem told us it was a concave mirror. So I'm going to draw it as such. Okay, my second step is to draw a horizontal. Now remember, I gave you the clues to draw these big enough and to be neat, okay? So I'm going to try to be neat by using a straight edge. Okay, step 3 is to find the radius and the focal point. Well, this problem told us it has a 12 centimeter radius of curvature. So I'm gonna make this my radius. And then I know my focal point is about half, or it is halfway. We're gonna say it's about right there at 6. All right. My fourth step is to draw my person. Now it says the object, or the person, is placed 4.5 centimeters away from the mirror. So my person is gonna be about here. Okay. So he's inside both the focal point and the radius. So I've done step 1, 2, 3, 4. Now we're ready for step 5. So my first line, orange, horizontal from the head, reflecting back through the focal point. So horizontal from the head, it hits the mirror and reflects back through the focal point. Remember, we're gonna put an arrow on the reflected line so that we can keep all of our lines straight. So the one with the arrow is the reflected line. Okay, my second line is the purple from the head through the focal point, reflecting back horizontal. Well, here the focal point is behind the head. So we have to assume, it looks like I didn't draw my mirror far enough. We draw it as if it's coming through the focal point, through his head, and then reflected back horizontally. And then my third line, the green line, is from the radius, reflecting back through the radius, of course going through his head again. So here's my radius. There's his head, so it's gonna come like this, hit the mirror, and be reflected back on itself. Okay? So obviously these 3 reflected lines are not going to intersect. So if they don't intersect, I'm sorry, I went step 6 now. I'm trying to find the spot where they intersect. If they don't intersect, I have to extrapolate the reflected lines back behind the mirror. Okay, and things aren't perfect, but it looks like they're gonna intersect about right there. So number 7, draw a head at the point of intersection. Draw my body back down to the horizontal. And from this, it's easy to see that my reflection is going to be magnified upright and virtual. Okay, remember virtual, it's virtual because I had to extrapolate. Okay, if I have to extrapolate these reflected light beams, then it becomes a virtual image. All right. We follow the exact same process if it's a convex mirror. So let's look at 12.3 on page 400. Okay, on 12.3 on page 400, it says we have a convex spherical mirror. So I'm going to draw my convex mirror. I'm going to draw my horizontal line. It says this spherical mirror has a 6 centimeter radius of curvature. Now remember, the radius is always inside the circle. So in a convex mirror, your radius is actually going to be on the opposite side as the object. Okay, which would make my focal point about right here. And it says the person is 2 centimeters away. So my person maybe is about right here. Okay, that looks pretty reasonable. So I've done number 1, I drew the mirror. Number 2, I drew the horizontal. Number 3, I found R and F. Remember, R and F are always inside the circle. Number 4, I drew my person. Now I'm ready for step 5 to draw my 3 horizontal, or my 3 lines. So the first is to draw a horizontal, and then it's reflected back through the focal point. So it's going to reflect back like so. My purple line is from the head through the focal point. So from the head to the focal point. But when it hits the mirror, it's going to be reflected back horizontally. Remember, these light beams aren't going through the mirror, they're being reflected off of the mirror. And then my green light is from the radius, reflected back on the radius. So as it's going to the radius, when it hits the mirror, it's reflected back. So here are my 3 reflected light beams. Determine where the lines intersect. Well, again, these are not going to intersect. So I extrapolate my reflected light beams. And it looks like they're going to intersect about here. I draw my head at the point of intersection, draw my body back down to the horizontal. And in this case, it looks like the image is going to be reduced, upright, and again, virtual, because I had to extrapolate the light beams, the reflected light beams. Okay, so hopefully that's a helpful review. That's all we covered the last week before spring break. And in our next video, we will move on to new material.